what's the best possible way of using models and working with them as thinking tools? So that's one. I think the second big takeaway, and this is again something that I picked up over a period of time, second big takeaway is that Excel is a lot cheaper than real life. So if you have ideas, if you have thought experiments that you want to try out, rather than rolling them out in real life, it's possible for you to, if you have the right skill set, right? And that's not a financial skill set, that's basically a problem solving skill set, where you take a problem, figure out how to structure it, and then put it together in Excel and run it and see what the numbers show you. So I think the second big reason for running this course is that I want to make sure that we all understand that Excel is cheaper than real life. Now, a model is only as good as the questions we ask from it, right? And a lot of time we're so focused on building models that our energy, our direction, our mindset is focused on the mechanics of the process rather than the reason or the inspiration. So what's the question you want to ask? And we have two major cases that we're going to work with through the duration of the course. But from a mindset point of view, within each case, there are multiple problems. Whenever you see a challenge or a problem that we present, a question I want you to ask yourself is, what's the question we're trying to answer? Why are we doing this? What's the objective? What's the purpose? What's the expectation? And so don't focus on the mechanics, don't focus on the terminology, focus on the context and the reason and the rationale for building it, right? So if you start from there, that's a good start. That's a good beginning for anybody else. Now, beyond this, there are certain elements of mechanics. There are certain common flaws and challenges that come up, and it's quite easy to get dissuaded or swept away by them. So we want to highlight those. And then, just like if you've come from a CS background, just like there are design patterns in CS, and there are patterns in machine learning, there are also patterns in financial modeling. And our idea is to sort of expose you to those patterns so you can work with those. All right, so that's one part. I think the second big part for me is that building a model is generally a great way of understanding how the business works. It's a great way of identifying what are the core business drivers you should focus on. And we'll, with both Maya as well as with GEMS, our idea is to work with the point of view that we don't want to just build the model, we also want to use the model building journey, the model building exercise as a way of better understanding how our businesses work. One common mistake and challenge that we see on a regular basis is that as founders, when we build models, we are generally, very focused on growth. We are very focused on the upside, mainly because, a lot of times our mindset is driven by growth and scale. But at the same time, there is some bandwidth that needs to be allocated and dedicated to understanding the downside and quantifying risks. So we will do that. Today, I think our big question is growth. So one of the most common challenges that we come up when it comes to building financial models is, where do numbers for growth come from? What's the possible source? How do we decide that? Is it just like 5, 10, 15, 20%? Do we pick a number from the air? Or is there a more, sensible, more systematic, more thoughtful approach that we can use for identifying growth, right? So that's the game plan. So now, I think a natural question that comes up is, in both Mayas and in GEMS, there is a lot of emphasis and focus on debt. And my question to you is, why should you worry about debt in a startup? One is that when we look at modeling from the perspective and from the point of view of a banker's lens, a banker is generally very focused on making sure that they get paid back, right? So they're not so much concerned about the upside, they're more concerned about the downside. That analysis is useful, that's one part. Two, I think if you look at if you are raising a round of funding and if you look at your term sheet is essentially debt masquerading as equity, right? So if you look at the terms of your financing and you look through them and you compare them to, let's say, a standard contract from, let's say, a high yield lender, you'll find that there are lots of similarities. So even if you model equity, even if you model financing from a mindset, from a perspective point of view, it's labeled, it's booked as equity, but it shares a lot of behavior with debt. So that's one. So I think one of the other big thing that comes up is that from a mechanics point of view, even though you're using it as a thought experiment, as a modeling tool, as a thinking tool, there are certain rules that still have to hold, right? So there's a list of never do's, do not do's that you're not supposed to do, that we do because we're not aware of them, or because that's never really covered in school. So we want to cover those. We also want to spend a lot of time on what I call cross checks. So the idea is, do we have two paths to a number, and do the two paths give us the same answer? We want to spend a fair bit of time on validating assumptions.